Creation had a beginning, and this was thought to be about 13.7 billion years ago. Now, this was first found by the astronomer Edwin Hubble, who discovered that in fact the universe is expanding. Stars and galaxies are spreading ever further apart, and he found this using something known as the Doppler effect. Now, the Doppler effect you can observe yourself anytime you listen to a large truck or a train go by. As it comes toward you, its sound has a really high pitch, but then it has a low pitch when it's going away. And this is because as it approaches you, its sound waves get pushed closer together, making them have a higher pitch. But then as it goes away, those sound waves get pulled apart, so the pitch is lower. Now, the exact same thing happens with light. So if an object is moving towards you, the light waves that it's sending to you will get pushed closer together, and they'll be more blue. The object will appear more blue to you than it would if it was standing still. Similarly, if the object is moving away, the light waves get pulled apart, and the object actually appears more red. Now, when Hubble was looking at the stars, he found that they all had a redshift. That in fact the stars were moving away. It seems like space is flying away from us. And he discovered that the stars which are further away from us were actually flying away from us even faster. And so through careful measurements, he was able to determine how fast each star was moving away and realized that the entire universe is expanding, it's spreading apart. And so, by calculating backwards, kind of working backwards in time from how far away things are and how fast they're expanding, he is able to run the clock back as things got closer and closer together, till eventually everything coalesced in this tiny point, this singularity. And that point he figured out was 13.7 billion years ago. And at that point it is thought that something happened called the Big Bang, a huge explosion that started off the entire universe and all the processes which form the materials that make us up and led to our existence. And so it all started in the singularity known as the Big Bang, a huge explosion. And actually confirmation of this idea was found in a strange place, in something called cosmic background radiation. Other astronomers were looking at the sky and they noticed that space itself was giving off heat. Now, a very low amount of heat, about 2.7 degrees Kelvin. That's about negative 270 degrees Celsius. So don't worry, space is still very cold, but you would expect it to have no heat. It's just empty. But in fact, they found this tiny, tiny little bit. And they began to take its spectrum to see what kind of heat it was, where the energy lied. And they figured out that it was exactly what we would expect if there had been a big explosion. It was exactly the type of heat that you would predict, something called a black body diagram. And what it was is this. If you remember from our talk on matter, that there can be matter and there can be antimatter. And then if they come together, they'll annihilate each other and turn into energy. So, when the Big Bang occurred, there was a huge explosion, and every time it formed matter, it also formed antimatter. And so most of this matter and antimatter eventually ran into each other and exploded in this flash of energy. So what the cosmic background radiation is it's the leftover heat from that explosion of the matter and antimatter very soon after the Big Bang. And so this discovery confirmed this idea of the universe beginning in a giant explosion called the Big Bang, about 13.7 billion years ago. Now there's a couple of odd things about the beginning of the universe that are worth noting. One is that at its beginning, at the time of the Big Bang, the universe must have had an incredible amount of order. And this is due to something called the second law of thermodynamics. Now the second law of thermodynamics states that for an isolated system, its entropy, its disorder, is always increasing. So what that means is through the 14 billion years that the universe has been around, its entropy, its disorder has always been increasing. And so now we can see, order in the world around us, but we know that that has to kind of be canceled out by disorder in other places so that the total disorder is always increasing. And so what this means, if we trace it back, as we go backwards, there has to be ever more order until we get to that original state, which must have been incredibly highly ordered to start with in order to get what we see today. It's kind of interesting. The other interesting thing is to think about where matter came from. So when the Big Bang happened, when it exploded to create this matter, for every time it created matter, it also created antimatter. And so most of this matter-antimatter canceled each other out, annihilated, and formed cosmic background radiation. And yet we're still here. We're made of matter. How did that happen? Apparently, for every billion quark-antiquark pair, for every billion matter-antimatter particle, there was one extra piece of matter. And so when they all canceled each other out, at the end of the day, there was a tiny bit of matter left over. And that tiny bit is what makes up all the stars in the universe, everything that makes up us. It makes up everything that we see. Where did that come from? This is a question that we don't have answers to yet.